Okay, on to question 2. Part A is to differentiate this function 4 ln of x over x to the power of 4. So this one here is the quotient of two functions. So you're going to use the quotient rule. So the derivative of this is the derivative of the top function times the bottom function minus the top function times the derivative of the bottom function over the bottom function squared. You don't need to simplify, so you can just leave it like that. Part B, calculate the gradient of the normal of the function y equals e to the x over 2 when x equals 5. So we're looking for the gradient of the normal, which is the negative reciprocal of the gradient of the tangent at that certain point. So we need to solve for the gradient of the tangent at x equals 5 and then take the negative reciprocal of that. So the derivative of this function to find the gradient is 1/2 e to the x over 2. So then you're going to substitute in x equals 5 and you get 1/2 of e to the 2.5 essentially, or you can rewrite this as e to the 2.5 over 2. So then the gradient of the normal is equal to -1 over e to the 2.5 over 2, which is just -2 over e to the 2.5. And that's it. Okay, on to part C. So a collector of Lego wants to make a cuboid display case with a square ends to house one of his creations. So, and it looks like this. He has 6,500 centimeters squared of perspex to make the 5 sides. So it's only 5 sides. It implies here that the ground is given to us, so we don't need to factor in that. What are the dimensions of the case that will give a maximum volume? So they're saying that they're square sides, so the side lengths are the same, but then we don't know the length. Well, it's just a different length. And we've been given the floor, so we don't need to consider that. And we've been given that the total surface area of perspex that we have here is 6,500. And what is that surface area made of? Well, it's made of 2 square interfaces, one on this side and then one in the back. So that's 2 lots of x squareds as an area. And then you've got here a face of x times y here, and it's been rotated once and then twice and then 3 times, so there's 4 in total. And then also, no, it's just been, sorry, you have it on this side, and then the side that you can't see in the back. And the ground is not necessary because it is given to us. So there's 3 lots of x times y. And then what is the volume of this? Because we want to maximize the volume. So the volume of this is given by the length times width times height, which is x squared times y. And to find the maximum volume, you need to differentiate this equation, but you can only differentiate with respect to one variable. So you need to substitute out x or y, and you can do that by using the surface area relationship. And it's easier to rearrange for y to substitute inside here. And so you have a expression of volume in terms of just x. So rearranging the surface area equation, you get y is equal to 6,500 minus 2x squared over 3x. So then this volume equation can be rewritten as x squared times 6,500 minus 2x squared over 3x. And you can see that the x's cancel over here. And then you can rewrite this as 6,500x minus 2x cubed over 3. So we can find the derivative of the volume with respect to x as 6,500 minus 6x squared over 3. Set this equal to 0 and then solve for what x value it is. So you can multiply the 3 to the other side and get nothing. And so this is equal to 6,500 over 6 and then square root that. And what do you get? Well, 6,500 over 6 and square root that is equal to 5 square root 390 over 3. You can convert into a decimal. I don't personally like to, but it's okay. And then, once you have this, you then want to solve for the other dimension of y. So you're just going to substitute this value into the y expression, which was up here. So then 6,500 minus 2 times this answer squared, and then divided by 3 times this answer, and that gives you 20, oh my goodness, 20 root 390 over 9. And you should probably put in units as well. So this is centimeters, and that is centimeters as well. And that's your answer. Okay, part D. A spherical weather balloon increases at a size as it climbs towards space. The diameter at the balloon at launch is 2 meters, and the volume increases by 10,000 centimeters cubed per kilometer it climbs. Find the rate at which the radius is increasing with respect to change in height when the radius is 200 centimeters. So the actual question is find the rate at which the radius is increasing, so dr, with respect to change in height, so dh. What is this equal to when the radius is equal to 200 centimeters? We've been given information here as well, where the volume increases at 10,000 centimeters cubed per kilometer it climbs. Okay, so the factors that are changing here are the volume, the height that it climbs, and the radius. And so we need to use chain rule on this expression to account for the 3 variables. So the missing one is v. So we're going to separate this out into dr over dv times dv over dh. We've been given dv over dh already, which is great. It's 10,000. So we need to find the derivative of r with respect to volume, which we can use the volume function for. Volume of a sphere is 4/3 pi r cubed. Deriving this function with respect to r gives us 4 pi r squared. And we're interested in when the radius is equal to 200. So just substitute in 200 right now. 200 squared. And what do you get? 200 squared, and then times by 4 pi, you get 160,000 pi. And then the reciprocal of this, dr over dv, is just simply 1 over 160,000 pi. So then to find my rate of change of the radius with respect to how high it climbs, it's going to be 1 over 160,000 pi multiplied by 10,000. And that gives me, well, I mean, you can see that there's 4 zeros here, cancel up with the 4 zeros over here. So it's just 1 over 16 pi. And you can put your units here as well. So the radius is changing at centimeters, and then the as it climbs is per kilometer. And that's it. Okay, part E. The function f of x is equal to 8 over x squared is shown. Give the area of the triangle made by the tangent to the curve at x equals n and the 2 axes. So it kind of looks like this. So this point is x equals n, and they want you to find the area of this triangle that is result enclosed by that tangential equation there. So how do we find this area? Well, we need the base and the height. It's a right angle triangle, so we just need to know the base and the height. And in order to solve for the base and height, we need to know the y-intercept and the x-intercept of this tangent equation, which means that we need to find the equation of that tangent at that point. So that is our goal here. And we know that the tangent at that point is x equals n. So the x-coordinate part is n, and so the y-coordinate part is going to be 8 over n squared. Okay, so let's find an expression for the equation of the tangent here. So f prime of x, you can rewrite this as 8x to the negative 2. So f prime of x is, you multiply it by negative 2, it gives you negative 16, and then x to the negative 3. So this is negative 16 over x cubed. And then we're interested in f of n. So then f prime of n is simply just negative 16 over n cubed. So that's the gradient. This is the gradient of the straight line. And then we know that it passes through this point, n, and then 8 over n squared. So using the equation of a straight line, y minus y1 equals m times x minus x1, where the y and the x are our variables, and then x1 and y1 are our coordinates at one given point. So the point that we're going to use is n and then a over n squared. So y minus 8 over n squared is equal to m. N was negative 16 over n cubed over x minus n. So then expanding the right hand side out, you get negative 16 over n cubed times x, and then it's a positive. It is a positive because you got negative times negative here, so it's positive 16 over n squared, and then here you've got negative 8 over n squared, which you can bring to the other side to become plus 8 over n squared. So this is y equals negative 16 over n cubed times x plus 24 over n squared. So that is the equation of the tangent at that certain point, and we need to know the x-intercept and the y-intercept. So the x-intercept is when y equals to 0. So then 0 equals negative 16 over n cubed times x plus 24 over n squared. So then solving for x, you get x is equal to, this is 16x over n cubed is equal to 24 over n squared. I'm going to multiply it by n cubed and then divide by 16. And what I'm left with is x is equal to 24 n cubed over 16n squared, which reduces down to 3n over 2. Okay, that is my x-intercept, and then my y-intercept is when x equals 0. So then y is simply just equal to 24 over n squared. Okay, so my area now is half of the base times the height, and the base is the distance from the origin to the x-intercept, which we just calculated as 3n over 2. And then similarly, the height, that is from the origin to the y-intercept, which we just said is 24 over n squared. So this is half times the base, which is 3n over 2, times the height, which is 24 over n squared. So you can see that the n's cancel out over here, one of them. 2 times 2 is 4, and then 24 divided by 4 gives us 6. 6 times 3, it gives us 18. So this is 18 over n, and that is my answer. Okay, we can move on to